Hi everyone, my name is K. Shravani, working as an assistant professor in Electrical and Electronics department from St. Martin's Engineering College. Today I want to discuss about power system protection and switchgear. Before going to discuss about the protection and switchgear, I want to give some information about what is meaning of power system. Here power system is nothing but it contains four categories. Power system contains four categories. What are the categories here? I will write here what are the characteristics of power system. First one is the generation. First one is the generation. Next, second one is the transmission. Transmission. Third one is the distribution. Distribution. And final fourth one is the utilization. Utilization. So here in a generation, here we can generate the power. Here we have the different types of generating stations: thermal generator, nuclear, wind we have, solar generators also we have. So here at a generating station, there we can generate the power. So in this generation, which are equipments we are going to use? Means main equipment is your generator. Generator. So what is the function of generator here? Which can generate the power, means which can convert the mechanical energy into electrical energy. And same as here we can use the transformers. Transformers. So what is the function of transformers is nothing but which can transfer the energy from one level to another level. So at a generating station, we are going to use the step up transformers, because at a generating station mostly we can generate the power 11 kV or 22 kV we can use. By using the different types of generating station, we can produce the amount of power of 11 kV something. So here we have to increase the voltages. We have to increase the voltages. There we can use the step up transformers. By using that step up transformers, we can generate it. We can increase the value of the voltages. Again we can use their bus bars. Bus bars. Why we are using the bus bars is nothing but we have to, after generating the power, we have to transfer the that amount of voltage we produced. By using the bulk amount of power or voltage, we can transfer by using this bus bars. And next, coming to the transmission. Transmission is nothing but, before going to discuss about the transmission, I want to give some information about the utilization. Utilization is nothing but we have to utilize the power. Where we are utilizing that power, where power is generating at a generating station is at a generating stations we are producing the power, and at a utilization we have to utilize that power. Okay, so nothing but home applications or industrial applications and agriculture applications, we are utilizing the power. So in that utilizing, most of the equipment we are going to is nothing but a motor. What is the function of motor? Which converts electrical energy into mechanical energy. For example, in the fan, I want to rotate the fan. So in that fan, we are using the single phase. If it is a home applications, domestic applications, we are going to use that single phase induction motor. So what is the function of motor? Which converts electrical energy to the mechanical energy. So where we are getting that electrical energy? From the generating station to domestic purpose, we are receiving the power, electrical energy. So between these two steps, generating power to utilizing the power, here we have the two steps again. What is that steps? Distribution as well as the transmission. So for here utilization, I am going to use, if it is a domestic purpose, I want to use 230 volts only. If it is agriculture purpose or industrial purpose, I want to use 440 volts only. Volts only. Okay, now here, see here. Here we are generating the more power, but here we are utilizing the less amount of power. So now here, we have to decrease the level of the voltages. So how we can transfer the level of voltages from one level to another level? We already know that by using the transformers, we can transfer the energy one level to another level. So in this distribution is nothing but, here distribution is nothing but a substations we are using. Distribution substations we have. In the distribution substations, we are going to use the transformers. Okay, transformers. We already discussed what is the function of transformer. Okay. Now see here, at a generating station we are using the transformers. At a distribution stations we are going to use the transformer. So what is the difference? Is nothing but at a generating station we are going to use the step up transformers, because there we need the output voltage is high compared to the primary side. Secondary side voltage should high compared to the primary side. Coming to the distribution substation, there we are using the step down transformers. Step down transformers. Why means, here at a consumer end we are going to use the less amount. So now we have to reduce the value of voltages from high to low. So that is the reason we are going to use the step down transformers. Not only transformers, we are there in a distribution substations we can use the feeders. Okay. And next we can use this all equipments, isolators we can use, insulators we can use. Okay, next. So where we are getting the now distribution substations will get power from the generating station. How power will transfer to the one place to distribution station? Means by using the transmission line. Through the transmission lines we have to transmit the from generating stations to distribution stations. So here we are going to use the high tension values, high voltage of conductors we are going to use. In this we can use the isolators, we can use insulators, we can use. So these, because high bulk amount of voltage we have to transmit from the generating station to distribution station. So in this, in 4 categories we are using the different types of equipments, right? Generators we are using, transformers we are using, bus bars we are using, and next to motors we are using. So all big equipments we are going to use for this 4 categories. This 4 categories is nothing but power system. These 4 categories is nothing but considered as the power system. Now coming to our topic. So what is our topic is nothing but today power system protection. Power system protection. So we have to protect each and every equipment. Why we need to protect each and every equipment means, see here we are going to use big components like a generators we are using, transformers we are using. The cost of transformer is more, and generator is also more. We have to protect. If suppose we are not care about the generators, transformer, whatever which equipment we are going to use in a power system, what will happen? After some time, after some years, it will get damaged if any fault will occur. So what are the types of faults which occurs in a power system is nothing but because of the over voltages, because of the over currents, and aging of the insulation or aging of the conductor. It will lose some applications. So that is the reason we have to protect. If not using any equipment protection, generator, suppose a generator will producing this amount of power, continuously it producing this some amount of power. So after working of these continuous hours, what will happen? Generator windings will get heat. Because of that heat, it will get burn off after some time. So that is the reason what we have to protect the generator. Similar like a transformer. In the transformer, we have to cool the windings also by using the mineral oil. Some extra we have to make cooling down of the windings, because we have to reduce the heat of that windings. Some types of faults will occur on the power system equipments. Okay, now see here, protection devices and switchgear. Now the protection devices is nothing but we are going to use 2 types of devices. One is the protection devices And one more is the switchgear devices. Protective devices are nothing but which can sense the fault. Protecting devices are nothing but which can sense the fault and again which give signals to the circuit breaker like a switchgear parts. Now coming to the switchgear is nothing but which can isolate the fault, after receiving the signals from the relay protecting device. These switchgear parts will going to minimize the value of fault and it can clear the fault and it will get the normal position. Means nothing but this circuit breaker will protect the healthy part of the power system from the faulty conditions. So that is the reason we are going to use the protective device as well as the switchgear devices. From the switchgear we can consider the current transformers and potential transformers also comes into the switchgear part only. Now see, okay, we are producing some amount or we are transmitting the power or we are utilizing the power, we are step downing the power. So while during this process, so we are getting some losses. Losses is considered as in electrical term, the losses are considered as a fault. So fault is nothing but abnormal condition. Fault is nothing but a abnormal condition. So in a power system, here we are getting the two major faults. What are the faults? Nothing but a symmetrical fault. Symmetrical faults. So one is the symmetrical fault. Okay. Symmetrical faults are nothing but a three-phase faults. Three-phase faults. All phases will present there. And the next one is the asymmetrical faults. Asymmetrical faults is nothing but a phase to ground, phase to phase, or we can say line to line, line to ground and double line to ground. These are the asymmetrical faults. Symmetrical faults is nothing but a triple line to ground or triple line faults. Now we are discuss how asymmetrical faults will occur. How asymmetrical faults will present on a power system equipment. Okay. So now for this I want to consider a three-phase transmission line. Here I want to consider the three-phase transmission line. Here I am considering the three-phase transmission line which are connected with the circuit breaker at a consumer end, which are connected at the circuit breaker at a consumer end. These three transmission lines are connected through the bus bars side. So this bus bar side we have to connect earthing switches. Earthing switches. These are nothing but a earthing switches which are connected, which are located at a bus bar side. Earthing switches. And this is nothing but a circuit breakers which are connected at a consumer end. Circuit breakers. Okay. Now, so how three-phase faults will occur? Okay. Before going to how three-phase faults will occur means when we energize the three-phase lines, while closing the circuit breakers, we have to ensure that these earthing switches will be off position. We have to make the earthing switches will be off position. So here while energizing the three-phase transmission line, while closing the circuit breakers, we forgot to make the earthing switches are off position, means the earthing switches also on position. In that case, we will get the symmetrical faults. Nothing but a triple line to ground or triple line faults will get. So this is the way to will get the symmetrical faults. Now we are going to discuss about the how asymmetrical faults will occur. Asymmetrical faults are categorized as into three types. What are the types is nothing but line to ground. One is line to ground fault and next one is the line to line fault and double line to ground fault. Okay. So these are the three types of the asymmetrical faults. So now here we have to discuss about how line to ground faults will occur. So here for this I want to consider one tower. Here this is one tower. Okay, this tower has cross arm. At the end of the cross arm we have to connect suspension type insulator disc. So insulation also we can use as a protecting only when any over voltage or any over currents will occur. With this suspension type insulator disc will protect the protect the transmission line. At the end of the disc we have to connect, we have to make the some conductor which is carrying the how much voltage is nothing but 132 kV line will connected at the end of the suspension disc. Okay, now see how we can suppose here we are using the 132 kV line voltage we are passing through this conductor. Now here we have to make that how many types of insulating discs we have to provide. So how we can make the types of number of discs is nothing but here we have to consider this is our line voltage, this is our line voltage. What is how much line voltage is passing through this conductor? 132 kV. So now here I want to calculate how many number of suspension discs we have to use for this 132 kV line. So how we can consider 132 kV and which is divided by the root 3. Now consider how at each disc how much current voltage will passes through this means nothing but 11 kV. 11 kV. So while calculating this value, here we will get approximately 6.9 value we will get. Okay. Now here we have to consider the safety factor. Safety factor. So what is the value of safety factor here? 1.5. So when you multiply this 1.5 into the 6.9, approximately you will get the 8 to 9. Okay, approximately you will get the 8 to 9. We have to use the 8 to 9 number of insulator disc for this 132 kV line. So now how L2 line to ground faults will occur means when over voltages occurs due to the lightning in a monsoon season. So what we have to do, what will happen means the flashover or means over current of over voltages will fall directly on this conductor, this 132 kV. So again here this line is connected to the ground, right? So that is the reason here we will get the line to ground faults. So when we will get the line to ground faults means when over voltages occurs due to the lightnings in a rainy seasons. So some over voltages will occur, flash over voltages will occur between this cross arm section to the line conductors directly. So in that case the insulation property of disc will reduces. That is the reason we are getting the line to ground fault. So remaining another fault is nothing but a line to line fault. Okay, line to line faults. How we are getting the line to line faults in a power system is, so when between the two conductors, when any switching operation will occur between the two line conductors, there we are getting the line to line means any birds or any tree branches or any snakes will touch the two lines. So there some short circuit will present in between the two conductors. There we are getting the line to line faults. So these are the faults we will get on the power system. Okay, what are the faults we are getting? Symmetrical faults we are getting and asymmetrical faults also we are getting. Now we are going to discuss because consequences of faults. So what will happen if faults will occur? What will happen? So here, see here. So consequences of fault. If faults will occurring like symmetrical faults occurring and asymmetrical faults we are occurring on a system, power system. So what are the consequences? Here the two types of damages will get. What are the damages? Two damages. One is the thermal damage and one more is the electrodynamic damage. So what is meaning of thermal damage? Thermal damage is nothing but if you are using the some insulation to every equipment, right? Conductors, whatever we are providing this some insulation. If the insulation property will reduces, if withstand capacity of insulating material will decreases, there will the temperature will goes on increases, it will get damage of the any electric winding of any electrical equipment. So that is the increasing of the temperature, we are going this will happen, thermal damage will happen. Okay, next here, and here we are going to what is another one is nothing but a electrodynamic damage. How we are getting the electrodynamic damage? Electrodynamic is nothing but electrodynamic will get when magnitude of the current will increases, magnitude value of current will increases drastically, like how much withstand capacity of conductor, but it increases the because of the falls up to like 10% or 20%. Okay, so electrodynamic dynamic damage is nothing but when magnitude of the current will goes on increases up to 10%, up to 10% or 20%, 10%, okay, 10%, 20%. So what will happen after increasing the value of current means, so here the shape of the equipment will get reduced, like a D shape of the equipment will happen. So that is the consequences we are getting, which like a thermal damage, while increasing the temperature we are getting the thermal damages, while increasing the magnitude of the current we are getting the electrodynamic damages. So these are the consequence falls. Okay, now see here we have different types of categories, like a generating stations we have, and what are the power transmission systems we have, distribution systems we have, utilization systems we have. So in that each and every system we are using different types of equipments. So now here most of the major faults will occurs on the transmission lines, because these transmission lines are always affected with the weather conditions, like rainy seasons or due to the fog, whatever, dust, wind, everything. These overhead, due to overhead transmission lines are affected with mostly. That is the reason major faults will occurs on the overhead transmission lines only. So up to 50% of up to 50% of faults will occur on only overhead transmission lines only. That is the reason we have to take care of more compared to the other departments, like suppose we have the controlling units we have, okay, controlling units we have, and generating stations we have, power transformers we have. So compared to all these, and underground cables also we have. So compared to the overhead transmission lines, these are getting more less effect, like underground cables are not affected with the weather conditions, right? That is the reason mostly we are getting the 10% of faults will get. But most of the damage faults will occur on the overhead transmission lines only. So that is the reason we have to protect the overhead transmission. Now I am going to explain how we can protect the overhead transmission line when fault will occur. See, these are the faults, transient faults and permanent faults. Transient faults are nothing but these are the temporary faults. We can call the temporary faults, like a line to line. When tree branch will come touches the two conductors, what will happen? Some short circuit will happen between the two lines. But how much time it will present means, so due to that over voltage, the tree branch will get smashed in a within fraction of seconds only. Because of that time, after that time, the fault will clear. So we are not providing the any protecting schemes to that transient fault. So this is the advantage, like we are not providing any. After some time the fault will clear automatically only. But coming to the permanent, what are the permanent faults? Permanent faults are nothing but a breakage of damage of the insulation or breakage of the conductor. So that is comes under the permanent. We have to take a severe of a permanent fault. We have to provide the protecting schemes for this permanent faults. So what are the protective devices? Protective device is nothing but a relay. Relay is the function of relay is nothing but when fault will occur on any transmission line which can sense that fault and which can give signals to the circuit breaker, which can't isolate, just it can sense. It can sense the fault and which can give signals to the circuit breaker, okay, which can give signals to the circuit breaker. What is the function of circuit breaker? After receiving the signal from the relay, this circuit breaker will open that contacts and it can isolate the faulty condition and it can protect the healthy condition from the fault condition. So that is the difference between the relay and circuit. Relay can sense but it can't isolate. Circuit breaker can isolate the faulty condition. See here, this is the basic operation of relay and how circuit breaker will operate while fault will occur. See, suppose I am considering here a bus bar, okay, I am considering here bus bar, okay, this bus bar connected with the CT, circuit breakers and relays, okay, relays. Now see here we are getting the fault, here we are getting the fault. After getting the fault, or suppose I am considering a fault is the overcurrent. So, overcurrents will occur because of the short circuit of any two conductors. The CT, current transformer, will sense that fault and it can give the, because of that overcurrent, it can energize the relay coil. Here relay coil will energize by taking the power supply from the current transformer. And this, because of here suppose I want to use the attracted armature type relay. So because these will works on the principle of attracted armature type. So because of that attraction principle, the magnetic flux will attract the contacts. These are the fixed contacts and this is the movable contacts. When attraction principle applied on this will pull down to the fixed contacts. When this moved contact will touches the fixed contact, when this touches the fixed contacts, it will give some signals to the trip coil. So this trip coil makes the circuit breaker is open. So initially the circuit breaker is in a closed position because if there is no fault in a system, so the circuit breaker is in a closed position. Circuit breaker has two contacts. One is the fixed contacts and one is the movable contact. This is the movable contact. Okay, initially there is no fault on any system, circuit breaker is the closed, normal condition we can say. When fault will occur, when the relay will give signal to the circuit breaker, it opens the contacts. This circuit breaker will open the contacts and between this is we call the dielectric media. This dielectric media overcurrents will occur. Okay, after here we are going to use the different types of dielectric mediums like oil, SF6, vacuum, air blast. Because of that the mediums, it can reduces the overcurrents, means it can reduces the fault and after that again it get the normal condition. So this is the operation of the circuit breaker and relay. Okay, now I want to show some video how relay will, why we are protecting the transmission lines only. Okay, why we are protecting the transmission lines only. I want to show one small video. Okay, this make you understand how video transmission lines are getting affected. Okay, so see here, worldwide we are going to use the electricity. Without electricity we can't live. So this is the way. See how how we can generate the power, how we are getting the power to the home applications or industrial applications. So this is the way. See here how we are getting. Okay, how we are getting the power from here. See, from generating station. Okay, from generating station through, this is our tower. Just now I explained that this is nothing but a tower. Okay, so tower, from this here will most of the faults like a line to grounds because of the failure of insulations. So failure of insulations, here we may get LG faults. Suppose there we can use circuit breakers and different types of relays and we can provide the protection to these transmission lines. After clear the fault, what will happen? It goes through the transformer. It goes to the transformer. Okay. Now, see, these are the equipments, big types of equipments. That is the reason we have to protect the equipments. So, economical wise also we have to consider, right? If one equipment will get damaged, so see here, it's a clear view of transmission, generation and transmission of the power. Okay, see, this is the way we are using. Now, see here, how we are protecting, okay, how we are getting the power from generating stations to generating station to the transmission, transmission to the distribution. So, see here, we are going to, this is the substation, in view of substation, there we are going to use the insulators and everything we are going to use, right? See here, how relay will work. Okay, now this is your relay. How relay will work? When we are providing the supply to this relay, this coil will energized, and after that, because this is, I am considering the armature type. So, because of the principle of attraction, it will work. So, when we are energizing the coil, it produces this some flux. Because of that flux, the moving contact will touches the fixed contacts, then relay will operate. This is the topic today we discuss. Okay, hope everyone understood. Thank you.